Welcome to our webinar. Thank you so much for joining us. So, as many of you are aware, this is a 5-part series. So, as per usual, we have 2 presents here from Optigo Networks. And today we have Sabatino Castaldo from Tech Controls. Many of you will recognize that. Previously, we've had Robert Lastinger. Robert is on the line as well, but Sabatino is going to be taking the lead on this one. So, thanks for joining us, Sabatino.
No problem.
Okay.
Thanks for having
me. We'll let you talk. Sorry I interrupted you. This is a good topic. We have made it into a 5-part series. If you aren't aware of that, we're on our 4th of the 5 webinars. So the previous 3 are available online. We'll send them out also in our follow-up email, and you can read through them or watch the videos. So we've broken down the different parts of the network, the different layers. Our next webinar at the end of June is going to be really exciting. It's 2 hours, and we are going to live on air configure a network, make all these things actually happen in real life instead of just talk about the theory behind them. So please, please, please register for that. Join us. It'll be 2 hours, and we cannot wait. All right, that's enough from me. I am going to hand it over to Dave and Sabatino. Enjoy.
Great, thanks. Hello, everybody again. And good morning. What we're going to do today is talk about the top layers of the networking stack, and we're going to start with some TCP and UDP in the transport layer. We're going to talk about the application layer, specifically BACnet, because that's one that we all use in this industry. But we're going to go through a bunch of different protocols and talk a bit about how they work at a high level. We're not going to go into the nitty-gritty detail because that would take months. To start into that, I've got a kind of chart here. Some of you may recognize this if you've taken any sort of networking course at a educational institute of some sort. You've seen an OSI layer. You'll have heard things like layer 2 switch or layer 3 router that we've talked about in some of the past webinars. Basically, on the left here, you'll see where it says OSI model. That's a traditional way of looking at it as a 7-layer, and that's what you get taught in an educational course of some sort. In the IT industry, we typically reduce that to what we call the TCP/IP model, and that's kind of the way we've organized this course. So in the first webinar, we talked about network access, which is the bottom layer there. Last time we went through the internet layer, which of course is kind of one of the big pieces to interconnecting devices on the internet. And today we're going to talk about the transport and the application layers. And this is really more about how data is exchanged between different applications and how they use that data. If you look at the OSI model with respect to that, it says there's a session layer, a presentation layer, and an application layer. And really, that if you think about presentation layer, HTTP for your websites, that's a presentation layer. The data really tells you how to display or how to show or how to describe the information. Whereas an application layer thing would be something like, FTP is another protocol that you can see on the right-hand side there. FTP just allows you to transfer files back and forth. So that's an application. At a session layer, you might have authentication and authorization, and things like SSH, encryption, that's something all happens in that layer. In the TCP/IP model, it's all wrapped into one thing. Really, it's what does the applications on the device do? How does it talk with the other applications on other devices, and how does it use that information? So I won't go into too much more detail on that. Just as a reminder of the network access layer, we talked about fiber, we talked about copper, how we connect different devices together, and went through that in detail. On the internet layer, we talked about routing packets throughout the network and out into the internet, and how that's done through gateways and IP addresses and things like that. And you can refer back to that if you want. Today, we're going to assume that that's all built, and we're going on top of that. And you may hear terms like voice over IP, and when you're over, you're talking about one of the higher protocols or the higher layers on this. If you hear things like BACnet over IP, again, it's a higher level protocol that works on top of the lower level protocol. All right. If you haven't seen this before, and this is kind of a scary diagram, don't worry about it. This maybe shows like 1% of the stuff out there. I might know 10% of it, and there's 98% of it out there that even somebody who's worked in this industry for 20 years doesn't know. Don't worry about it. Just figure out what you need to know and work from there. All right, and another thing to refer us back to our previous webinars, we had built up these layer, basically the networking layer and the physical / link layer within the different switches that you can see here, and the routers, and how they're all connected together with the devices, connected ports. And we built that up over the last 2 webinars. What we want to do today really is talk about how the different applications talk to each other, and that's really difficult to describe on top of this diagram. So really, we put a few notes on here. If you look on the upper left side there, we talk about our NC600. It has a web server built into it, and that allows you to basically use HTTP over TCP, the protocol stack, and allows you to go in and administrate and set up all the device settings for all the switches in the network. If you look on the center of the screen, you've got SNMP over TCP, and SNMP is kind of a health information about a switch or about a router on a network, and you can again you can communicate with that. You can get that information back. It's similar to what BACnet does. Speaking of BACnet, we've got BACnet over UDP on the left hand side. So those devices that are sitting there talking using that protocol. So basically, it's hard to actually draw a diagram. Overlaying it over on the network like this, but you just have to visualize it as the different applications on these different devices. So just to tie it back, not the greatest diagram, but it's but if we want to try to connect everything together. And when we do our full build next time, we'll kind of go through the details of each of these as we build it out.
And Dave, if you don't mind, if I can jump in there real quick on that last slide, it's worth noting here. Just keep in mind, I know a lot of you probably know this already, but it's really want to stress that the application layer is not specific to any one device or network you see on this diagram. If, for instance, most of these have some type of web interface, so they're all accessible via the application layer at every level. So we're showing this diagram because this is what we keep referring to with what we're going to build for you when we set out to do this live. But the application layer and the applications that exist within it are at every level of this. They're down to the smallest device and all the way up to the ONS NC600. So we're going to be able to see that as we move forward.
Yeah, and it rides on top of the physical network that we built. Great. Okay, so hopefully we've thrown a bunch of information out here, and throughout the rest of this webinar, we'll crack open some of that information and give you a better idea of what it is. All right, so I'll hand it over to Sabtino for transport layer TCP.
Yep, so the transport layer. This is going to cover all of the TCP and UDP. This is just 2 types of transports that we could take advantage of, and the transport layer just defines the level of services and what kind of connection we're making. So there's many more protocols. We're not going to talk about those in this seminar. You've already heard about it in past seminars, and if you haven't, it's a good idea to watch those as well. So basically, the TCP is kind of like that that email that would be sent out. You know, the data integrity is very important. There's an acknowledgement on the other side that information gets sent, and it needs to know that it is there and it needs to be there. Anything you download and keep for long-term storage, that is going to be done under a service of TCP. The UDP, on the other hand, and this is where we take advantage of in the HVAC world over IP UDP, lets us handle things like broadcasts, for example. In other layman terms, if you're downloading, if you're streaming a video online, or if you're streaming a video security camera, that would be a UDP kind of communication. It's connectionless. It doesn't care what you get or how many times you get it, or if you missed a small packet, you'll get the next packet later on. So in our world, it's something like an outside air temperature that we can do that broadcast, that global broadcast or that local broadcast.
And it's also worth noting on between TCP and UDP, you can sometimes use both for the same type of application. So, but there's usually a preference for one over the other depending on the type of information you want. So it's not, you're not hard coded in. You could do email over UDP, but you wouldn't want to. You could do a security camera over TCP, but that would be very inefficient. Yeah, and it might cause you problems with what you see. So the basic advantage for TCP is data integrity, and the basic advantage for UDP is performance. That's and with the slight advantage of broadcast traffic, which we take advantage of in BACnet quite a bit. But most traffic you're going to deal with day to day will actually be TCP. So if you have a supervisor or you're moving trends and schedules, a lot of times we do that over TCP. UDP is really, we take advantage of that in the controls world when we're more interested in live data. So if you're updating data from a point, you don't care what that data was doing 5 minutes ago. Typically, if you're running a program or logic, you really care about where that data is right now at this second. And that's why in controls, we tend to favor UDP for a lot of our network traffic. So that's it.
All right. And just to give you an analogy that that might make sense in kind of human communication, TCP being connection oriented and being something where it's really important that you get the information. It's very similar to, say, an air traffic controller talking to a pilot. They need to make sure that the communication is very is acknowledged by the other side, and it's repeated back if we need to make sure that we're getting the right information. And if we don't get the right information, we need to ask for you. So this is just a little script of an air traffic controller and a pilot. They use a specific terminology. This is a controller. Identify yourself, who you're talking to. Do you copy me? Roger, yes, I do. This is flight 123. So they're back and forth, and the tower wants them to change their altitude in their course, and that's to repeat that back so they know. Obviously, if they don't do this, they could get the wrong information or interpret it wrong, or you could miss a zero on there and be at the wrong altitude, and you're going to get planes crashing into each other. So if you have a similar type of application and you want to make sure that you're getting that information, the integrity of that information, you use TCP. So think about emails, think about your website, that sort of thing. So UDP is more like a teenager talking to a parent, and Monica wanted me to say a little voice in this one, but I'm not going to.
Come on, dude.
That's too embarrassing for me. I'm not quite that good of an athlete. But you know, a teenager could get home and they've got a long list of things and slang they're using. You know, the parent is getting the gist of the conversation, and you know that the blah 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 there doesn't really matter. It's the general, you know, feeling for how that team is doing. But it's all about the real time interaction and making sure that you know I'm getting that. You know, that the team is able to gain that information, even if they may not use it. But in the end, you know, the team says, "Oh, I want to go over to my friend's house," and the parent is saying, "Oh, hold on a second, you know, I need to tell me more about that." So it allows you to hone in on the information you need and ignore, to some extent, the information you don't need. So again, and they brought it up earlier. That's sort of like you know, a video or a voice call, that sort of thing, where you know, even if you get a little bit of jitter in there, it's okay. You can still get the gist of the conversation, or you know, you get a little bit of fuzz on your screen. That's all right. So the same concept, and in this, trying to bring it back down to, you know, a real human interaction.
Just a disclaimer, we're not encouraging you to ignore your children.
No, not at all. In fact, this parent is not ignoring it. In the end, they're getting the right information.
Fair enough.
All right. So that was the transport, and pretty much everything goes over either TCP or UDP. There are other protocols, but those are the two main ones. So up at the top, application layer. We'll have to talk about that, and I'll hand it back to Sabtino again.
Yep. So the application layer, that's what we see here. We have the HTTP and HTTPS. Now these are two of the services we're going to be using on this TCP IP transport layer using the application of HTTP and HTTPS. There's many other services. We're not going to talk about those, but this is where in our controllers, for example, you were able to either turn on or turn off those services. We're not going to talk about ports. That's something else. But the application itself, that layer is going to happen on over HTTP or HTTPS. So looking at that application layer, there's many protocols that we can look through, like HTTP, HTTPS. This is basically all of that data traffic that we send over the web interfaces. SNMP, this is Simple Network Management Protocol. It's the equivalent for us in controls of a BACnet network, MSTP. This is computer-to-computer communications. You're talking about what the IT managers typically use for services. SNMTP, the Simple Mail Transfer Protocol. That's how we receive our emails. NTP for time and DNS for domain. We've heard of these acronyms before. We've seen them. We've dabbled with them. Maybe we understand them 100%. You know, we come from many different backgrounds, but all these services are all in the application layer, and there's many more. We're just not going to look at all those. These are the ones we're interested in.
Hundreds and hundreds of more.
Yeah.
So, the other interesting thing about the application layer is that the applications can be designed in different ways in terms of how they communicate. And one important architectural difference is whether they're designed as a client-server application or peer-to-peer. So typically, I'll delve into the client-server. You know, we're talking about a centralized server which is something that contains the application itself, useful data, web pages, you know, bank information, you know, whatever that may be. And a client wants to connect to it and makes a request and gets a response back. And so that's a typical client-server application. There's many applications like that. We can mention a few. You know, an FTP server, for example, is a client server where I request a file and it downloads the file to me, or vice versa. I upload a file. and it acknowledges it. The good thing about a client server system is it's very stable, and it has that centralized information, so it's in one place, and it's controllable. Bad thing about it is you can get some real networking bottlenecks if there's thousands, for example, of clients trying to talk to that. This is especially true on web servers or databases and things like that, where you can get denial of service attacks on those systems. And once you overload it, those clients can't get the information. So you have to get either a cluster of machines or VMs or a big beefy server to serve up the information. Do you want to talk about peer-to-peer?
Was I doing the peer-to-peer? Sorry about that. Yeah, so the peer-to-peer, and if we can take a look back at the protocol layer just one more time, just one slide over before. Yeah, so I want to mention also that the each protocol or each service handles the application. They don't care how you get there. We don't care that you're going through server to server, server client, or peer-to-peer, which would have been server to server in our case, but peer-to-peer. Whatever network you're on, it doesn't matter. As long as you're able to get to it, we'll transfer that data to you. So one of those data is going to be UDP. Let's go back and take a look at peer-to-peer. So peer-to-peer allows us to have data exchange between devices. So we can control a certain amount, but less globally. So unless you're able to get into each and every device, you can literally control each and every device and how they can communicate over the network. And that's all about distributed technology, distributed data, streaming, file exchange, all that kind of information can be sent over a peer-to-peer network. These are also very good for direct or broadcast messaging. We do that very often. We talked about it, global or local broadcasts. The pros, they're cheap and easy to scale. You just build one perfect set that will be foolproof, and you could just build on that. You could scale it up or scale it down. The con is that they're a little bit less controllable over the data packets because you're dealing with one pole value, or you'll have to go into each and every single one and modify how often they send that data out, or expect that data, or request that data, etc.
So, and I'll jump in real quick on this. Client to server and peer-to-peer are not really device specific. So these are these are typically functions of a device. So an example would be a controller might have a web interface. So that would be client to server, but it might also talk on BACnet or Modbus, and that relationship may be peer-to-peer or client to server. So a lot of times if you have a device, it will do, depending on what it's talking to or what the protocol is, it will do a lot of these at the same time. It'll do peer-to-peer for some types of communication, do client to server for others. So it's not device specific at all. It's just really a function of whether you're serving up a web page or you're trying to do BACnet communication. So you really got to pay attention to what you're doing with that data. And even then, sometimes with BACnet, for instance, you can do peer-to-peer or client server. So, and same with Modbus. So, we're just really identifying the types of traffic to help you understand what you're looking at. But like I said, it's important to note that a server is not just client server. A client is not always a client. It can also do peer-to-peer. It just depends on what you need to do at the time.
Quick admin note, if anyone's having trouble with the audio, trouble hearing us, you can let us know. That would be really helpful. Thank you. And thanks to those who have already chimed in.
My wife. Okay, so one of the specific application protocols is BACnet, and I'll let the guys talk about that.
Okay, so we've kind of touched a little bit already on BACnet. We'll talk a bit about BACnet over IP. This is BACnet over IP using UDP for most of our translations. Peer-to-peer communication. It looks like IT, so it's going to have the same kind of physical topology, physical connections. We're going to use the Optigo switches. We'll use the one server, and the devices will be connected directly to that bus. We'll see that, and we saw that earlier. However, there's the difference. There's lots of broadcasts. We can communicate through networks, through connected or remote networks. This will allow us to do BBMD, BACnet broadcast management devices. We can talk over MSTP through routing if we're going to stay on the IP layer. All this to say there's no authentication or encryption necessary for UDP transactions. Remember, that was just a message that's sent out. It was that teenager who kept on saying all kinds of words, and you caught a couple of them, and you'll catch the rest next time around. So that's just the overall layer of the BACnet over IP. And then we talk about BBMD. So that's BACnet Broadcast Management Device. This is, to put it simply, it allows you to communicate between different networks. That's the simplest way to think about this. This is remote buildings. It could be, different floors. If you had set up different VLANs, you want to communicate through those, you would need either configured routers with tagging, where Robert discussed that on a previous webinar, or BBMDs that allow you to process the whois command, and that whois will allow us to discover all of those devices on the network.
And we're going to talk a little bit more about that in the live demo, but it's worth stressing. BBMDs are not needed for routing all BACnet traffic. They're specifically needed for routing broadcast traffic. So if you have an IP device on one network and you have another IP device on another, you don't need a BBMD for them to talk to one another. If you identify each of them to one another, you can set a network value or an outside air temp to be written into another controller on a different VLAN. You don't need a BBMD for that at all. The BBMD is simply needed for broadcast traffic. So things like a time sync to the network, a discovery, COV broadcast, if you're broadcasting a single value to an entire network, that's where you'd need a BBMD. But I want to stress the difference between BBMDs are not necessary to get across a VLAN at all. They're just simply necessary if you want to have broadcast traffic on the other side of that. So just want to specify there. So you can set up a network without one, and we frequently do. But if you need to have one, then you'll need to have one on both sides of a VLAN or a different network.
Mm-hmm. They do make it easy to discover your devices.
They certainly do.
You set them up, you discover, you bring them in. At that point, you no longer need them unless you have to do the other transactions that would require broadcasts across those networks. Okay. What do we see? Perfect. Okay. So as live demo, we set up 3 Eclipse controllers. Not sure if you see. There you go. 3 Eclipse controllers, an S1000, a 303, and a VAV. We set them up all on the same network. Network IP, BACnet network port, network 1, port 47808. Because we're on the same network, we don't need to enable anything for BBMD, etc. Through ECnet, we basically discovered the controllers, and we sent that broadcast to discover them. We just added them to our database. I've already added them, so they don't show up full color. They'll show up grayed out. So we have them here. I've added them to our database. We then went along to configure them, and we built a small code. Robert built this one, and we're basically showing this live on the communication from the S1000. It's just generating some random counter. We're updating that counter every 3 seconds. We're pulsing it. There's our value. And we're sending it over the network as a global broadcast, a local broadcast, or a pull. On the remote devices, the ECY 303 and the ECY VAV, also IP devices, we are receiving, for example, the global broadcast that we set up. In this case, we said any device. It's a nice addition that we can actually receive from any controller, any device, a broadcast values. That means if I wanted to use more than one sensor to bring over a network to this device for redundancy, for any kind of protections, we could decide from any device I will receive this broadcast, or specifically from this device ID, which is the device ID of my S1000 in this case. Our local broadcast was the same setup with specifically the S1000, and we set this up as a receive broadcast.
And this, can I jump in there real quick, Sabatino, on this one? This it's worth noting, this functionality to receive a broadcast from any device at that object instance, that's only available because we're using UDP. That wouldn't be available with TCP because you have to identify destination. So this is one of those where I can tell my controller, hey, any analog value that broadcasts on object instance 1000, I'll take that value. So I could have multiple devices. But that's just showing that the benefit of broadcast, that we can have one device transmit and many devices receive. So what something is showing you there is only possible because we're using UDP for this. If this was TCP, we would have to do it a different way.
Mm-hmm. And then finally, we have polls, where the device itself will poll in this case, the master or the peer device, the 105.094, which is the S1000. We're asking it for its analog value 1002, which is this one here. And we're getting its value every 15 seconds. So we're just asking every 15 seconds. And there you have it. So we replicated the exact same scenario in the ECY VAV. We could, and like we said earlier, we can scale this. This setup can be scaled. We can put this in every controller, and every controller will be able to get that broadcast, wait for it, they receive it, or they can pull it individually. Of course, larger and larger sites will require you to start increasing your poll times. You don't want to have too much of a busy network. So for the polling, we just set that up for 15 seconds on each of the controllers.
Can we increase one real quick, Sabatino, to 45 seconds just to showcase the difference between the two controllers?
Absolutely. Here you go.
There we go. And so you'll see on those two controllers, they're both polling instance 1002, but you'll start to see one of them will fall behind here as we poll. And we're going to touch on it again. We're showing broadcast and polling here, and polling is peer-to-peer. Polling is one controller going to another, directly to another controller and asking for that information. But imagine if we had 600 controllers, and 600 controllers all wanted to go to the server, the S1000 here, and ask for outside airtime. That is not efficient from a network perspective. That's not a good idea. Now, if we broadcast outside airtime, all 600 of those controllers can then get that value, and you have considerably less network traffic to allow for that. So that's why these TCP versus UDP, we keep coming back to that. That's why it's important to understand why we use those things and why you might want to use them for different types of network traffic, because it allows for things like that. So in BACnet, it allows us to scale very, very well.
Using broadcast. And they already fell behind. You see it.
Absolutely. So now the benefit of polling, it's worth noting before we step away from it, the benefit of polling is I don't need BBMDs. If I have different devices on different VLANs, I can poll those devices, and I don't need a BBMD to accomplish that. I just need to know what the device's IP and UDP port are to get to it, and then the object instance. Whereas to receive a global broadcast or a local broadcast, to receive that, I have to either be on the same network, or there has to be a BBMD on my network to rebroadcast those global broadcasts. Local broadcasts will only ever be local. You'll never receive a local broadcast over a BBMD. If you do, there's probably a bigger problem, and you'll have something to sort out. But typically, over BBMDs, you will only receive global broadcasts. And we probably want to show them this. Go ahead, Sotia.
The network.
Mm-hmm.
So we'll show the S1000.
Yeah. And so here we have a station which is receiving those broadcasts and doing polling as well. And we can adjust the polling here. And if you look at the way Sabatino has the controller configured, so he can show you where the polling is real quick. Under the poll service, yeah.
Mm-hmm.
Get
there. We've got our tuning and we got our poll.
There we go. So here, this might be a little small, but you can see where Sabatino has the poll service set up, and we're polling devices. This is what many of you are familiar with this interface and have used it quite a bit. And polling is not broadcast traffic. So that means we don't, if we have a network with 1,000 IP controllers, we do not need a BBMD to poll those points. If you go to the BACnet network, Sabatino, and show them where we configure the IP address for the device. So you'll see here that the device is identified by an IP address and a port. So we use Discover to find it, but once we've identified it, we don't need a BBMD to talk to that. We can simply poll it. And that's what Tritium does here in the station. That's typically what happens. But if you go into the points, we can configure points on the S1000 like we did here. We can configure points to receive broadcast. And you'll see under the read type there that I've configured 2 of those points to receive broadcasts from the controller. So they're not being polled, or they're being polled extremely slowly. So we're taking advantage here on a controller. We can do this with hundreds and hundreds of points, and we can take advantage of that broadcast feature, because once a controller broadcasts those values, everybody can take advantage of it. So this station can take advantage, the other controllers can take advantage, and that packet only gets sent once instead of every controller asking that controller for information. But it's worth noting that because we've configured this controller by IP, then when we set up VLANs, the layer 2 switches will know where that device is. It will all route, and we can get to it without having to use broadcast. So BBMD is only necessary for broadcast traffic.
Quick question here from one of our attendees. Do you need to be on the same subnet?
That if you have VLANs, no, you can be routed on different subnets entirely. If you're just setting it up, if you're just setting up a network and you don't have VLANs, and let's say you have just 10 devices and a unmanaged switch, then yeah, you probably want to be on the same subnet to make things easier on yourself. But you can route. We could do this over the internet. It's not that we advise you to expose controllers to the internet, but if we had 2 controllers that were on the internet, we could actually route to them on entirely different addresses on entirely different places on the planet. As long as we had a network path to them, we can, and of course we were talking on port 47808, which is what we're doing for BACnet. We could poll those devices and get data. So no, they don't need to be on the same subnet. But if they're not on the same subnet, you'll have to have some means by which to route that traffic. So you'll have to have a router or a managed switch or some way to move that traffic between the subnets. And was that the last question, or were there any others, or should we move forward?
Now, if anyone else has any more questions, let us know. That's it though for now.
Okay, and did you have anything else you wanted to show him, Sabatino?
I don't think so. I think
we could show real quick, if you want to show adjust the COV broadcast time on one of the S1000 on the global broadcast, so that it only changes for maybe every 2 values or 3 values instead of every single change under the properties. you could showcase that so they could see how we're configuring that to broadcast. It'd be under AV 1000. Yeah.
1001. So let's say we go with a global broadcast. We could just change that.
We could change the COV increment to 3, and then it would only transmit when the values change by 3, and you'll see that on the other controllers. Once that change is committed, it'll happen almost instantly. You'll start to see the network values marked as global. They'll update less frequently. So the reason I wanted to mention that is this goes back to something similar to a client-server relationship where it's not the same, but the concept is the same. We made a change in one location, and now now everybody benefits from that change. If we're polling a device that's more peer-to-peer, and if I want to change, if I have 600 controllers polling, say, an air handler, then if I want to make a change, I have to go into each one of those controllers and adjust how they poll, right? Because it's just going peer-to-peer. With a broadcast, it's one controller is kind of sending out information to everybody else. It's kind of, in a sense, it's acting like a server for that information. It's almost a bit of an analogy, but it works for this case to kind of showcase the difference between client-server and peer-to-peer. Although you could make the argument that it's still peer-to-peer, but you have to forgive me for this one.
Great line.
Yeah. But I think, and then I guess that one probably does it for the live demo.
So now that BACnet being one of the premier protocols on the application layer for what we're talking about in the OT network business, there are plenty of others, potentially in the thousands of protocols out there. I want to go over a few of the common ones and talk a little bit about what they're made of and how they do their communication at a very high level. Each one of these we could probably go, you could probably go to a 4-month course to get all the details of how the messaging works and what the details of it. And I won't go into that. And you're welcome. But feel free to go online and get as much information as you can. If you're interested in, for example, finding out about email, just go out and Google SNMP protocol, and it'll give you all the messaging. But before I get into that, we've been talking about ports. This is a routing thing. We talked about IP addresses being how we route to a specific location. So a server, for example, at an IP address may have multiple applications running on it or multiple services of different types. So the way we differentiate is by using a port. So you'll see quite often in the URL, for example, in HTTP, a IP address or a host name, and then a colon, and then a number, a port number. 80, for example, as you see here in the chart, is the default port for HTTP. It's not necessarily always that case. You can actually change these port numbers. This chart that you're looking at here just shows you what the default is. So, for example, what's a good example? DHCP has 2 ports that it runs its service on. They're both UDP based. In a 67, 68. You can change that if you want. Any server will have a configuration when you set it up. And in some cases, people do that specifically for security reasons, because if hackers know what the normal default port is and they're trying to penetrate your network, they're going to use that. So quite a few people, for example, when they set up a web page, will set it up on 8080 or 8000 or some other number that they come up with, just to kind of obfuscate that from the hackers. So port numbers very important for differentiating traffic that's intended for one application or another. So I won't talk about too many of these in detail because I'm going to do that a little bit later on. So let's go through some of the common ones. So so HTTP, and that stands for Hypertext Transfer Protocol. By the way, I actually had to look up some of these when we were going through the list. Too many 3- and 4-letter acronyms that we throw around on a daily basis that we don't actually know the real meaning of. But sorry, that's a diversion. But this is a protocol that was created maybe 30 years ago, and basically the original intent was it to be a presentation layer application, which allowed you to, using a hypertext markup language, HTML, you could actually design how you want it to be, the information that's transferred to be displayed to the end user in a web browser. Obviously, over the years, that's changed considerably, and there's much more advanced functionality that can be done using it. Again, you can run scripts, you can access backend systems, and HTML 2.0 and so forth have broadened the scope and capability of this, and it's become basically the de facto way to communicate on the internet. So HTTP uses a client-server model. Your web browser obviously being the client application, and your web server being your server application. It also uses TCP, so where we have a request response that's acknowledged. You can see on the diagram on the right, we have a very broad example of what a client request would look like. It has a header, it has a body, and then the response, again, with a header and a body. The other interesting thing here is we can talk about HTTPS as well, which is secure HTTP. So now you're just making sure you have an encrypted tunnel to access the web between the web server and the web client, and that'll use a different port as well. So typically, things like bank applications and things like that will use the secured version of it. You may actually hear things about REST APIs and different API-based exchanges, and a lot of that is actually sitting on top of an HTTP protocol. So, for example, a REST API is actually under the hood. It's an HTTP request and response to call an API. So it basically uses all of the HTTP functionality to allow it to do either encryption or authentication, things like that. So it's actually quite interesting today that we're actually building protocols on top of protocols, and a lot of applications, and even into the OT world is starting to use APIs on top of HTTP as a kind of primary means of communicating back and forth. So this is a very important protocol. It's probably one of the better ones to learn the basics of. However, as it's expanded over the years, there's almost an infinite amount of information about it and infinite amount of uses for it. So I recommend taking your time to go through it.
Dave, if I could jump in there too, I just wanted to.
Yeah.
When I get a lot of questions about APIs, especially the REST API, since that's one that's becoming more popular, and the analogy I like to use about that is if HTTP is the language you're talking, REST API is just a subset of that you've agreed upon. So it's just a list of words and phrases within, say, if HTTP was English, REST API is just a small group of words that you've agreed to use to communicate. That's all it is. So it's and they just have to be formatted. So it's a specific way to ask for information. So you say, I'm going to say, can I please have this value between this time and this date, right? And you're just going to say it in a very specific way, and then somebody's going to respond with the exact data you requested. So it's still HTTP. It's just a very specific version of it, right? So it's just a subset of that. So if you think about it as a language, that's just a portion of the words you're agreeing to use in a specific way. So, but it's still HTTP.
Yep. Great. So we talked about a TCP, and I want to bring up an example of a UDP based protocol. So VoIP, or voice over IP. So we talked about the term over before, and using one protocol over another. Voice is really about creating a stream of audio packets and doing it over an IP network. This is considered a peer-to-peer model. You're actually communicating between two different endpoints where you're sending the voice packets from. It's actually also an interesting one in the respect that it actually has two different protocols or two different messaging sets, and I'll talk about that in a little bit of detail in a second. But the reason why they use UDP is because of the real-time aspect of it. UDP is much faster, and you're going to get a real-time packet transfer, so your voice isn't delayed. Because you can imagine that you've been talking on telephone all your life, on an analog telephone, and then you go over to a digital voice over IP telephone, and there's a 3-second delay. That's just not going to be reasonable for communication. However, if there's a little bit of jitter on the line, like we maybe have been experiencing earlier, that's okay. We can still figure out what people are saying. So that's why UDP is used in VoIP. Right. And then so I mentioned the dual protocol. If you look on the right-hand side in that diagram, so this is just a message back and forth between the different pieces of the network. You may have heard the concept of SIP phone. I can't remember what SIP stands for off the top of my head anymore. Sorry, a little bit of a blockage there, but anyway, it doesn't matter. SIP is actually what the device is used to establish the communication, so connection between the two different sources. And that can be UDP or TCP, it really doesn't matter. The protocol itself doesn't really care, and it's just trying to initiate a connection. And then you see bearer or media down the bottom with the RTP stream. That's the actual voice packets being passed back and forth, and that is definitely over UDP. So this is one application where you'll have multiple ports and multiple different protocols being used to achieve one application. So that from that perspective, it's kind of interesting. Won't go into too much detail on those messaging. It's that those are just typically what different things happen in what order. So next, so we'll talk a little bit about email now. So email uses SNMP, and again, this one's a little bit of an interesting one, and I'll talk about that, the reasons for that in a second. So obviously, the key here is to exchange email packets back and forth between different email clients over the internet, and so there's lots of SNMP servers out there that exchange, and you know who you're servicing in terms of their email address. So you get if you got the proper routing, you can send those packets to the right server. So again, this is a case where you don't really care if it's delayed a bit, but you do care that you get exactly the message that you want and that it's acknowledged that it arrived. You don't want emails that are missing sentences or kind of half there, that sort of thing. That's obviously not going to help from an email perspective. And really, it's a client server as well. So if you look at the diagram, you're sending an email. It uses SNMP to talk client server to the SNMP server, so it sends the email packet up to the server. Then the server will route it over the internet to another server using an SMTP protocol again. And then that email is sitting there waiting for the recipient to come and pick it up. This is where it gets interesting because in this case, the recipient doesn't use And the interesting difference between those two is one of them will leave the email on the server side, one will download it to your client. Not much else different between them. So that's SMTP. If you're interested in getting more information, I'd look that up on the internet. Another interesting one we mentioned earlier, SNMP. We're starting to get alphabet soup here. It's hard to differentiate them sometimes, but this is really the BACnet of the IT world. So this is health and information about different devices being exchanged so that you can manage them. Typically, an SNMP agent exists on an application on let's say a switch or a router. It sends traps out using UDP when it runs into problems, and the SNMP master agent can go and get information about it, like how much uptime it's had and things like that. So again, this is a client-server model, but it's using UDP this time. The interesting thing about it is it's a little bit unreliable because of that. So you might get missed alarms or missed traps, I should say. In which case you don't actually know that server died. So SNMP is it's got its pluses and minuses on the IT side as well. This is one of the ones I had to look up because I couldn't remember what SSH stood for, but it's kind of sneaky, secure shell. Basically, this is about being able to remotely access using an encrypted tunnel a server and be able to run commands and so forth on that server. This is TCP based, and basically this one is, as you can see on the right hand side, there's a bunch of messages that are established to create a secure tunnel, and then you just start exchanging information, really command and response in terms of OS operating system commands on that remote machine. And one more, which is Secure File Transfer Protocol, SFTP. FTP is the unsecure version of this. And again, this is using TCP because you want to make sure you get the whole file down. If you're missing a piece of it, that's just not going to work. And it's client server based. So a client will establish, interesting enough, in a lot of cases, an SSH secure tunnel, which it will use to talk. So you're combining multiple protocols in some applications. And once it's done that, it's going to pass files back and forth based on the FTP protocol. There's not a lot of detail to go into on this one. And there's many, many, many more. And I won't go into them here, but please feel free to look them up on the internet now that you've got some basic understanding of how it all fits together.
Great. So I'm going to ask we'll keep the questions to a minimum. We will get back to all of the questions by email if we don't get them here. But one that I wanted to address from Nick, what is the point of COV registration if COVs are going to be broadcast? He's trying to understand how a device knows to broadcast on COV or to choose unicast or keep quiet altogether.
Well, we probably want to go into that in detail. So obviously feel free to get back to us. But at a basic level, there's a subscription. There's a COV subscription. Then there's a COV broadcast. Some BACnet devices and some controllers, they support the ability to send a broadcast. But what you're probably more typically looking at or seeing from, like, if you're looking at a supervisor or a Jace or any other thing, you might subscribe to a point, which is a bit different. COV broadcast is very efficient because the controller is choosing when it wants to transmit. It's looking at the value. It's determining it changed by whatever parameter I set. So I said if it changed, like for instance, if I said if it's 1 degree, if it changes by 1 degree, go ahead and broadcast that value. So that's very efficient because no other controller or nothing on the network needs to ask it any questions. They just simply sit back and wait, and the controller itself determines when the value is worth transmitting. So that's why we wanted to showcase that one, because it is the most efficient way to move data around a network. But it's not the same as a subscription. And there's a lot to go into there. So if you want to dive into that one, we're definitely want to help you, but send us an email or give us a call at tech support and we'll cover it in detail with you.
Perfect. That's great. So we'll get back to some other questions through email. We are out of time. So thank you so much, Dave and Robert and Sabatino, for your time. Thanks so much. Have a good rest of your day.